Alright, welcome to the pneumatics unit. This is video 1. So for this unit, I want you to be able to calculate the mechanical advantage of a pneumatic system. I want you to be able to calculate the force that a pneumatic system can provide. And finally, I want you to be able to explain how to assemble the pneumatic system, because there's several parts to this. Alright, first thing we need to do is we need to talk about pressure. So what pressure is force per unit area. So when we go to calculate pressure, we simply take the force and we divide it by an area. A classic example is stilettos versus snowshoes. The reason why we have snowshoes is so that we can take the area and make it larger. So notice, as area grows, as it gets bigger, the pressure becomes smaller. So the force would be your body weight, and that's not going to change. So if you have snowshoes, you have a great area, so there's less pressure on the snow, allowing you to walk on top of the snow. Stilettos, on the other hand, have a very small area. So the smaller the area becomes, the higher the pressure becomes. So if your body weight stays the same, if you wear stilettos, then you have a very, very, very small area, so there's a great pressure. So the units for this then will be force over area. So newtons per square meter, because we measure force with newtons, and square meter for area. Now, this does have a special name, the Pascal. So it's a derived unit. So a Pascal is a newton per square meter, and a newton is a kilogram meter per second squared. So the Pascals get quite, can get quite involved. Now, that's obviously the metric system. In the imperial system, we measure force with pounds, and we measure area with square inches. So PSI, pounds per square inch. And that's really all there is to pressure. We have atmospheric pressure, which is right around 100,000 pascals. Got tire pressures in your car, maybe 40 to 50 psi. So there's all kinds of things. Now, for a gas, when we talk about pressure, really what comes about is the fact that the gas molecules are bouncing around and they're colliding with the wall. So, like, think of a tire. They're colliding with the inside wall of the tire, and that applies a force. That applies a force on the wall. And every time they collide with the wall, they're going to apply a force, and they have a little tiny area, and that leads to the pressure inside, gas pressure inside that tire. Now, since it has the ability to flow, air is a fluid. So air obeys Pascal's principle, liquids obey Pascal's principle, a lot of things do. So what exactly is Pascal's principle? And notice we named the unit Pascal after Pascal. Pressure applied to a fluid in a closed container is transmitted equally to every point in the fluid and to the walls of the container. So what that means then, if I have some sort of container and I have a gas inside of that container or a liquid, they're constantly moving around. Those gases are constantly wiggling around. So if I were to measure the pressure here on that wall, it would equal the pressure here on this wall. It would equal the pressure here. It would equal the pressure here. So the pressure would be the same on every single wall of the container holding that gas or liquid. And that seems kind of childish, I know, but we can apply it to something else. We can apply it to lifts. So let's say I have a different kind of container, one with movable walls. So here on this side, F1 and A1, I have a piston which I can push down. And when I apply this force on this piston, that generates pressure, because pressure, so let's say P1, is force F1 divided by area 1. What Pascal's principle says is that that pressure is transmitted equally throughout this fluid or this air or this liquid. So when I come over here, this other piston will experience that pressure and it will begin to lift. So I have this P2, which is F2 divided by A2. And what Pascal's principle is telling us then is that those two pressures are the same. So what I can do is I can set these two fractions equal to each other. And then I can do just a little bit of algebra. I can do some cross multiplying and some dividing, and I find that this force F1 equals, and then that'd be A1 divided by A2 times that force F2. Now that gives me my mechanical advantage, this right here. And that's one of your learning goals. So by doing a division of those two areas, I can calculate the mechanical advantage of this system. And this is how like a car jack would work. We got a small reservoir of oil that we can apply forces to, and then it lifts up the other side. Now something else with gases, while we're talking about it, we do have the ideal gas law, and this is something you'll go into more detail in chemistry. And this basically says that the pressure in a gas is temperature dependent. So as the temperature rises, the pressure rises. Now, you'll lovingly learn to call this formula piv nert. But notice how temperature and pressure are directly related. So as temperature rises, pressure rises. Now, something you have to keep in mind then, this is one reason why you need to check your tire pressure in the winter, because as temperature drops, pressure drops. And you can lose pressure in your car tires. So you always want to check your car tires in the winter. We also have some other laws here, Boyle, Charles, and Avogadro's. But all of those are, deal with the ideal gas law. All right, kind of a shorter video, but we will hang it up here.